Okay, so in this section, we're going to multiply rational expressions, and it's going to be part one. So in a previous course, when you looked at these fractions, let's say you wanted to multiply, let's say 3/5 times 10/11. So 3/5 times 10 is 10/11. One approach that you took in that course, when you took that particular course, was you learned that when you're multiplying fractions, you multiply the numerators together. So you'd say something like 3 times 10, and then you'd multiply the denominators together, and so you'd say 5 times 11. All right, so that's one approach. Then what you did next was probably that you rewrote each of the composite numbers. See, 3 is a prime number, 5 is prime, 11 is prime, but 10 is composite. So you wrote 10 as a factor as a product of prime numbers. So you said, well, that's going to be 3 times 5 times 2. Remember, 10 is 5 times 2. Those are prime numbers, divided by 5 times 11. So remember, we factored 10. I'm using the word factored. We factored 10 as a product of prime numbers. So remember, every composite number can be written as a product of prime numbers. And then what you did next was you said, well, my first factor in the numerator is 3. Will that reduce with a factor in the denominator? And the answer is no. My next one is a 5. Will that reduce with a factor in the denominator? The answer is yes, because you see this 5 and this 5, so they both have 5 in common. So you said 5 divided by 5 is 1, 5 divided by 5 is 1. And then you have the 2, and that factor 2 will not reduce with anything in the denominator. So then you'd said, well, the answer is going to be 3 times 1 times 2, which is 6, divided by 1 times 11, which is 11. So you get 6 over 11s. Okay? Now, the other way you could have done that was to say, and this is probably what you did, 3/5 times 10 divided by 11. See, these are just numbers. So what you did, but this is important because it's going to be needed in a little while. But you said, all right, well, 5 and 10 I can reduce. They're both divisible by 5. So you said 5 into 5 is 1, 5 into 10 is 2. And that's about all you can do. So then you said 3 times 2 is 6, 1 times 11 is 11. Okay? But now this is probably what you did in the course that dealt with multiplying fractions. But this is important because this is going to be needed in a little while. So how does that look in terms of rational expressions? The expressions containing variables, let's say. So let's look at this example. So I'm going to go ahead and write rational expressions here. All right, so let's look at the product of these two rational expressions. Suppose I wanted to multiply, so we're going to multiply. Now suppose we had x minus 3 divided by x plus 5 times 2x plus 10 divided by x squared minus 9. Okay? All right, now, when multiplying rational expressions, just like we did when we multiply these rational numbers right here, we rewrote, in this case, we rewrote the composite numbers as a product of prime numbers. So we factor 10. We factor 10 as 5 times 2. So just like you did in the past, you want to factor the numerators and you want to factor the denominators. You want to write these you want each factor to be prime. So I wanted each of those factors to be prime. So x minus 3, I can't do anything else with, so it's prime. So I can't factor any further. X plus 5 is prime. Now 2x plus 10 is not prime because I can look at 2x plus 10 and factor out a 2. They both have a 2 in common. So far I have this. I have x minus 3 divided by x plus 5 times 2 times x plus 5. So that's what I have so far. And then x squared minus 9 is not prime because you know you can factor this because that's the difference of 2 squares. So all that stuff you learned in a previous chapter on factoring, you're going to use in this chapter dealing with rational expressions. So x squared minus 9 is the difference of 2 squares, so that's x plus 3 times x minus 3. All right, and then you can, if you want to, you can write this like we did here as one fraction, but you really don't have to. All you got to do is just look at each of the factors and see if I can reduce anything on there. But the issue is going to be this. When we go into division soon, when this is going to be a division problem right here instead of multiplication, don't get confused because here, if you leave it like this, you kind of overgeneralize, and you're gonna try and reduce factors in the numerator and the denominator when this is a division and not a multiplication. So be careful. So you may want to, if you don't have to, and I'll rewrite it in a little while, but you may want to rewrite this as one fraction. So x minus 3 times 2 times x plus 5 over x plus 5 times x plus 3 times x minus 3. All right, now you didn't have to. It looks a little bit more complicated, but I'll go back and use this one as well. And then if you look at each factor, my factors are in the numerator. My factors are x minus 3, 2, and x plus 5. So look at your numerator. Can I reduce this x minus 3 with a factor in the denominator? In other words, does x minus 3 occur in the denominator as a factor? And the answer is yes. So that means that these two factors, they have an x minus 3. So just like it did here, where these two factors are both 5s, that means that these factors will divide into each other. So 5 and 5 is 1, 5 and 5 is 1. Just make sure you understand that when you cross these numbers out, you really have a factor of 1 in its place. So when I cross this out like this, I really have a 1 in its place, because remember, x minus 3 divided by x minus 3 is the same thing as 1 over 1, which is 1. All right, so just always remember that. All right, my next factor is a 2. 2, if I look at my denominator, there are no other factors that 2 will reduce into. Those are just expressions, x plus 5, x plus 3. You don't see something like a 4 or a 6 or an 8 or a 10 or anything like that. And the next factor is an x plus 5. And I see an x plus 5 occurring as a factor in the denominator. So when I reduce those, I get 1s in their places. And so then you get 1 times 2 times 1 is 2. 1 times x plus 3 times 1 is x plus 3. And so there's your answer. But just remember that most students will not rewrite it like this. They'll go from here, and I'll go ahead and rewrite it. They'll go from here, and this is what they're going to do. And there's nothing wrong with that. Just remember that this is multiplication. This was division. You couldn't do what I'm about to do. You'd have to do an extra step, and you're going to see this in a little while. So this is what you're going to do. So I just rewrote this. So you're going to say, all right, I have an x minus 3 occurring in the numerator as a factor. In my denominators, both denominators right here, does x minus 3 occur as a factor? And the answer is yes. So I'm going to get the 1s in their places. X minus 3 divided x minus 3 is 1. X minus 3 divided x minus 3 is 1. My next factor is a 2. Does 2 occur as a factor in the denominator, or can I reduce this 2 with anything in the denominator? And the answer is no, because I don't see a coefficient of, let's say, 6 or 10 or 28, things like that. I don't see anything that's an even number down here as a factor. Now be careful, this was x plus 10. You couldn't do it because 10 is not a factor. Your factor is x plus 10 if that was a 10. So x plus 5, I see one down here, so I can divide those out, and in its places I get 1s, a factor of 1s in its places. So then I get 1 times, notice this is times, 1 times 2 times 1 is 2. 1 times x plus 3 times 1 is x plus 3. So that's the idea you're going to use. So it's very similar to this, except you're dealing with variables. All right, so let's look at some examples, some more examples. Now, what they're going to do first, now for most students this was pretty easy because these were not monomials. So let's do one with monomials, with monomial factors instead of binomial factors like you see here, or binomial polynomials like you see here. So let's suppose we had this. Let's suppose we had, and again I'm going to want to multiply. So all the directions will say here is multiply. We're going to do division in another video. Let's suppose you had this. Let's suppose you had 3x divided by y squared times 7y divided by 4x. So 3x divided by y squared times 7y divided by 4x. Okay, so if you want to, you can write this as one fraction. You can say 3 times x times 7 times y, things like that, over y squared times 4 times x. You can do that. There's nothing wrong with that. A lot of students won't do that, but if it helps you, then go ahead and do that. Because remember, when you multiply two or more fractions, you can multiply all the numerators together, then you multiply the denominators together. That's what this is. So then what you can do next is reduce your common factors. So notice that these are all monomial factors, monomials. A 3, an x, a 7, a y. Here you have two factors of y, you have a 4, and you have an x. Okay? All right, now, if you need to, you see this y squared? You may want to, I'm going to go ahead and use this one. You may want to rewrite that y squared just to help you. You don't have to. At first, you may need to rewrite this as y times y, because y squared means y times y, times 7y over 4x. All I did was I rewrote this y squared as y times y. And then you go through each of those monomial factors and you see if you can reduce them. For example, the first one's a 3. My first factor's a 3. Does 3 divide out with any factor in the denominator? The answer is no, because I don't see a 9, I don't see a 6, I don't see a 3, I don't see a 12, and so on. My next factor is an x. Do you see a factor occurring as an x down there? The answer is yes. So you cross those out just like you did here. Oops, just like you did here, the x plus 3, x minus 3s, x plus 5s. But when you do that, just make sure you put ones in their places. So you do this. You put ones in their places. All right. And then my next factor is 7. Does 7 occur as a factor in the denominator? And the answer is no. I don't see a 7, I don't see a 14, I don't see a 21, and so on. My next factor is a y. Does y occur in the denominator as a factor? And the answer is yes. I have two factors down there, but you see I only have one factor y right here. So you can only reduce one of those. It does not matter which one. So I'm going to put a 1 here and a 1 there. And so then I get, that's all I can do. So then I get 3 times 1 times 7 times 1 is 21. Y times 1 times 4 times 1 is 4y. And there's your answer. Now, let me just say this. If you had left the y squared as y squared, this is what you could have done. It's up to you. That's y squared times 7y over 4x. So just go through the same process. So you have a factor of 3. There's no factor of 3 that you can reduce with down here. I see an x. I can reduce it with this x. So put a 1s in their places. There's a 7 here. 7 will not reduce with any factor in the denominator because I don't see a 7, a 14, a 21, a 28, and so on. I see a y. There are two y's down here. So what you can do if you don't rewrite it as y times y is you would say, all right, y into y is 1, y into y squared, I'm left with one of them. So in your mind, you're thinking, all right, that means I have two y's, so when I divide one of them out, I'm left with only one of them, so y to the first. Okay? So you just cross out the exponent and just reduce it by 1. And so then you get 3 times 1 times 7 times 1 is 21. And then y times 1 times 4 times 1 is 4y. And you could have done the same thing here. See how we wrote it as one fraction? So you could have done things like this. So these x's divide out, you have 1s as factors in their place. These y's, now remember that's 1 here, one factor y, because that's y to the first. Here you have two of them. I can only use one of them. I can only reduce one of them. So I'm left with one factor y. And then you get 3 times 1 times 7 times 1 is 21. Y times 1 times 4, well, y to the first times 4 times 1 is 4y. Okay, so that was that. All right, let's look at this one. All right, suppose we had 8x divided by 2 times x to the 5th divided by 4x squared. So 8x divided by 2 times x to the 5th divided by 4x squared. Now, if you look at this one, you see this numerator has a factor of x, and this numerator has 5 factors of x's right here, and this denominator has 2 factors of x. If you need, and then you see a 2 times a 4. If you need to, you may, in this particular case, and these are all monomials, when you have monomials, it might be better sometimes if you rewrite it like this. So in other words, you see this, I have 8 times x to the 5th. Well, remember last semester, when you multiply like bases, see you're multiplying here, that's multiplication. When you multiply like bases, you add exponents. So x to the 1st times x to the 5th is x to the 6th. I have 8x to the 6th. So it may be easier to actually write this like we did here as one fraction. And then over here, 2 times 4 times x squared is 8x squared. Okay? And now look how easier this becomes just by rewriting it like this. So the multiple ways of rewriting it, you want to rewrite it so that however you rewrite it can help you. So these 8's right here, see this 8 and this 8, they both divide out. You're left ones in their places. Now, remember in your mind, you have 6 factors of x over here, you have 2 here. So it's kind of like saying this, x times x times x times x times x. So you have 6 factors of x in the numerator, you have 2 in the denominator, and then you reduce. So one set divides out, another set divides out, and that's about it. That's all you can do because you no longer have any other factors of x's in the denominator. So then you have x times x times x times x, which is x to the 4th, over 1 times 1, which is 1, so you just get x to the 4th. That's what this is. Okay, but also keep in mind last semester you learned that when you divide like bases, you subtract exponents. So 6 subtract 2 is 4. All right, but to be on the safe side, just in your mind, think about, all right, I have 6 factors of x in the numerator. I have 2 in the denominator, so since I have less in the denominator, all of those will reduce into the numerator. So that's going to be 1 here, and then when I remove 2 from here, I'm left with 4. So remember, when last semester, see how it relates. Last semester, when you divide like bases, you subtract exponents. 6 subtract 2 is 4. And so all you're left with is 1 times x to the 4th, which is x to the 4th, over 1 times 1, which is 1, and so the answer is x to the 4th. That's the answer. All right, let's look at this one. Now, the monomial ones are a little bit more challenging for students. They are challenging versus this. These are a little bit more challenging for students. All right, number 3. Let's suppose you had, let's suppose you had 4a squared b over 12a cubed b to the 4th times, let's say, b squared over a cubed. So let's suppose we had this. So 4a squared b divided by 12a cubed b to the 4th times b squared over a cubed. All right, now again, see how you have this numerator has b's in it, and this has some factors of b's as well. This denominator has some factors of a, and this has factors of a. It is a good idea. It is a good idea to go ahead and write it as one fraction. Write it as one fraction. It will help. So I'm going to have 4. You got to remember some things from last semester when doing this, because last semester when you multiply like bases, see how I have b times b squared. B times b squared. When you multiply like bases, you add exponents. 2 plus 1 is 3. So I'm going to get 4 in the numerator. I'm going to get 4a squared b cubed. So it's important that you see this. This is what you learned last semester. The product rule. This is a product rule. When you multiply like bases, you add exponents. Now in the denominator, you see this a cubed times a cubed? Same idea. When you multiply like bases, you add exponents. A cubed times A cubed is A to the 6. Again, the product rule. Product rule. So here I'm going to get B 12, A to the 6, B to the 4th. 12, A to the 6, B to the 4th. All right, so now let's reduce. So let's start with the 4. 4 can reduce into 12. No, I'm going to go ahead and rewrite this a little bit better. So you get 4, A squared, B cubed. I'm going to lose some space here. And then 12, A to the 6, B to the 4th. All right. So this 4 and 12, they both have 4 in common. I always use the greatest common factor here. So 4 into 4 is 1. 4 into 12 is 3. All right. My numerator, here is A squared. I have two factors of A. I have some factors of A down here, so I can reduce. So you see I have A's and A's, so you can reduce. Now remember we talked about earlier. I have 2 over here in the numerator, but I have more of them in the denominator. So all of these will divide out with the 6 that are in here. So I'll be left with, I had 2 here, I have 6 here. So I'll be left with 4 down here. So that's to be a 1 in its place right here. So A squared divided A squared is 1. A squared divided A to the 6 is A to the 4th. Over here, I have some factors of B. I have 3 of them. I have 4 of them down here, so I have more down here. So all of these, when I reduce, all of these will be gone. You'll be left with a factor of 1. But over here, you took out 3 of them, so you're left with 1 of them. So is that quotient rule, again, when you divide like bases, subtract exponents. All right, so notice 4 subtract 3 is 1, so that's why you have 1 down here. All right, and that's about all I can do. So my numerator, I'm going to have 1 times 1 times 1, which is 1. In my denominator, I'm going to have 3 times A to the 4th times B to the 1st power. So that's 3, A to the 4th, B. So that's the answer. Okay? All right. So let's look at a couple more, and then we'll be done with those kinds of problems. All right. Suppose we had, let's see. Let me try and do. All right. Let's try and do this one. All right. So this is going to be number 4. So you have negative 5 A cubed over 3B to the 3rd power times 2B squared over 15A. All right. Now, again, it's a good idea if you need to. It's a good idea to go ahead and write this as one fraction. So if you look at this, I have negative 5 times 2 is a negative 10. That's my numerator. A cubed times B squared is A cubed B squared. My denominator, 3 times 15 is 45. Use your calculator. And then I have A, B cubed. All right, let's just go ahead and put them in alphabetical order. All right, now let's reduce. Let's get the negative 10 and the 45. They both have 5 in common. That's my GCF of negative 10 and 45. So 5 into negative 10 is a negative 2. 5 into 45 is 9. All right, look at the A's. I have 3 factors of A up here. I have 1 factor of A in the denominator. So I have more up here. So that means that all these will go away. Remember, you only had 1 factor of A. So you can take away 1 from the 3 you had up here. So you're left with 2 of them. So you get A squared. All right, now the B squared and the B's, B cubed. I have more down here. So remember, it's kind of like you really have this. You have B times B over B times B times B. That's what you're thinking. So these B's divide out, you're left with 1s in their place. These B's divide out, you're left with 1 in their place, and you get 1 over B. So you're left with 1. So if you need to rewrite it like this, you rewrite it like this. Nothing wrong with rewriting it. So you have 2 up here, though. You have 3 down here. So all of these will divide. So you can say B squared into B squared is 1. When you divide B squared into B cubed, you're left with only 1 factor B left. So that's, you see, these 2 are removed, and you're left with 1. So that's where that B down here comes from. And so the answer is going to be, let's see, negative 2 times a squared times 1 is negative 2a squared. 9 times 1 times b to the first, so be careful. You still have some b's down here. 9 times 1 times b to the first is 9b. And so there's your answer. Okay? All right, so that's going to take care of this one. So all we did here was just multiply fractions where the factors were monomials, monomial factors.